Okay, I'm going to work through a linear programming problem, and this is the one from the D1 workbook, question 1 in fact. It was a bit easier than me making up my own question, so here we go. The question's up in the top right. The feasible region of a linear programming problem is represented by these given inequalities. On a graph where x is between 0 and 30 and y is between 0 and 40, draw a suitable diagram to represent these inequalities and indicate the feasible region. Well, I've got autograph up ready and I've got paint up ready for me to do some calculations. So the graph will be given to you generally in a linear programming problem. Okay, so it'll already be drawn out for you. You just need to draw the lines that the inequalities correspond to. So if we look at the first one, just to give you an example, I can write these straight into autograph, but that would be cheating to start off with. So I'll just show you where things are coming from. So I'm going to look at the line x plus y equals 30. Okay? So first thing you do is you think, right, okay, what is y when x is 0? So let's put x is equal to 0, so y must be equal to 30. Okay, so that corresponds to a coordinate on the graph, 0, 30. And when y is 0, okay, well, when y is 0, x is 30. X plus 0 is 30, so x must be 30. And that gives us a second coordinate, 30, 0. Okay, so we know 2 points where this straight line goes through, so we can just draw the straight line. So I go on to autograph, I can type in x plus y is less than 30, press return, and autograph draws it going through 0, 30 and 30, 0 as we thought, and it's already shaded in the top section of this line. Now if you needed to figure out which side of the line you needed to shade away, by the way, we shade off the region that we don't want. Select a point either side of the line. So the easiest one to deal with in this case is going to be 0, 0. Don't ever pick a point that is on the line. Always pick a point that is off the line. So 0, 0 will do. So I look back up at my original inequality. If x is 0 and y is 0, 0 plus 0 is definitely less than 30. So that is in the region I want. Okay, so that makes sense. Okay, and that is how you would progress to draw these lines and choose the regions. Okay, so I'm going to type in the next one. You can always use autograph to check your answers. Okay, obviously not in the exam, but to show you what's going on. So here's the line 2x plus y is less than or equal to 40. Okay, you can put in x is 0, so y is 40. If y is 0, x is 20, because 2 times 20 is 40. Okay, so you can see that they are coordinates on the actual line itself, 0, 40 and 20, 0. And then you can pick a point either side of the line. Let's do 0, 0 again. 2 lots of 0 plus 0 is definitely less than 40. So this side of the line is the area I want, and I shade off the area I don't. Okay, let's type in the next one. Y is greater than 5. Okay, remember that y is equals 5 is a horizontal line through the point where y is always 5. The coordinates along that line, y is always 5. And I can also type in the next one, x is greater than 4. Okay, that's a vertical line going through 4, 0. And finally, the line y is greater than or equal to a half x. So it's a line with gradient 1/2 and it will go through 0, 0. So y is greater than 0.5 times x. Okay, so there is our region. It's the unshaded region in between. Okay, so you can see that there are actually 1, 2, 3, 4, 5 significant points here. Okay, 5 vertices to the feasible region. So that will get us the full 5 marks. Now, if I just drag up to see the second part of this question. So use your diagram to find the maximum value of f on the feasible region in the case where f is 3x plus y or f is x plus 3y. Okay, so let's clear that and let's write in f equals 3x plus y to start off with. Okay, so we need to select the point on the feasible region, one of the vertices, okay, that gives us the maximum value of 3x plus y. Okay, so to do that we really need to figure out the coordinates of those points. Okay, remember we want to maximize. Right, well, if we look at our feasible region, the 0.45 here will not give us the maximum. Okay, because if we think about the line 3x plus y, it's going to come in from the right and it's going to hit one of 3 points here. This point, or this point. Okay, there's no real point in looking at these 2 points at the bottom, these 2 vertices here. Okay, one of them we can read directly from the graph, so that's 10, 20. So if we substitute the values 10, 20 into this, okay, so 10, 20. So f is 3 lots of 10, which is 30, plus 20, which is 50. Okay, so that could well be the maximum for this line, but we need to check the other 2 as well. Now, how do we actually go about doing that? Well, if we remember back to core 1, then we use simultaneous equations to figure out the intersection points of 2 straight lines. Okay, so if I look at this one, so my red line was x plus y is equal to 30. So I've got x plus y equals 30, and it is intersecting with the green line, which was x is equal to 4, I believe. Yep, x is equal to 4. So substitute x is 4 into this equation, and I find that y must be 26. So the coordinates of the intersection point is 426. So let's put that into my profit function, if you will. So 3 lots of 4 is 12. Okay, and y is 26, so 12 and 26 is 38. okay, which isn't as much as the 50 that we found from 1020. Okay, so that wasn't quite so good. There is one other point that I need to consider, and that is this intersection point here. Okay, so that was the intersection of y is equal to 0.5x, or y is equal to half x, so y equals, let's write 0.5x. Go into decimals for once. Makes a change. Okay, 0.5x and 2x plus y is equal to 40. Okay, so substitute the top equation into the bottom equation, and I will get 2.5x, because I've got 2x plus 0.5x, that's 2.5x, equals 40. Okay, so let's double both sides, so I get 5x is equal to 80. That'll make things easier for me in my head. So 5x is 80, x must be equal to 16. Okay, so if x is 16, y must be 8. Okay, so 16 and 8. If I refer back to my profit equation, okay, so f is 3x plus y. 3 lots of 16 is 48, plus 8 is 56. So f is equal to 56. So that was greater than the 38 that I had last time and the 50. So the coordinates that maximize f is equal to 3x plus y is actually 16, 8 on the vertex of my feasible region. So 16, 8. Ooh, didn't write that well. There we are. That'll do. Okay, so that was my solution to part I. Okay. Similarly, you can then substitute those 3 points into x plus 3y and determine which coordinate, which vertex will give you the maximum in that case. Okay, I'm not going to do that